Hey guys, we are looking at an absolute value inequality here, okay? When you are solving problems like these, there are four possible answers you might get. You can get an and inequality, an or inequality, no solution, or all real numbers, okay? Now, obviously, I'm just doing one here. If you want to see a video where I do an example of each in one video, I will link it in the corner, okay? All right, but let's go ahead and solve this. So the first thing I want to do is make sure that my absolute value bars are by themselves on one side of my inequality, okay? So in this example, we're good. They're already alone. If there happened to be like a +4 here, or it was being multiplied by something, I would want to get rid of those before I tried to solve this, okay? The second thing we're going to do is we are going to split this into two different inequalities, okay? And if you're wondering why we're doing this, again, I will link a video explaining why we do this, why it works. We didn't just make it up. It has a reason why we do this, okay? But the first one, we're just going to drop the bars and leave everything else the same. So it's going to be x minus 4 is greater than 5. The other one is also going to be x minus 4, dropping the bars. We're going to flip this sign so it's less than and change the sign here so it is -5. Okay? The other thing we need to know, remember I said there could be four possible answers, right? Well, the no solution and all real numbers, they have to do with when my absolute value bar is alone on one side. If this number is negative over here, your answer is either going to be all real numbers or no solution. So this is positive, so it doesn't apply to this problem. So we just need to know if this is an and inequality or an or inequality. Okay, now again, in that video I linked earlier, I'll explain why this is, but one way that is pretty easy for us to tell is just to look at this sign, okay? When my absolute value is alone over here, this is a greater than sign, and we can think of that, it kind of sounds like greater, right? I know that's not how you spell greater, but when it's greater than, you can think of greater, meaning it's going to be an or inequality. If it were a less than sign, it would be an and inequality, okay? All right, but let's go ahead now. We know it's an or inequality. Let's go ahead and simplify these down so we have our x's alone, okay? So here I'm going to add 4 to both sides, and I end up with x is greater than 9, or, again, I'm going to add 4 to both sides over here, and I get x is less than -1, okay? And that is my answer, okay? Let's go ahead and see what it looks like on a number line. You should stick around for this because it's very exciting. We have 9 and -1. So I'm saying x is greater than 9. I'm doing an open circle on 9 because it can't actually be 9. If there were a line under here, meaning x is greater than or equal to, I would do a closed circle, but it's not, so I'm doing an open circle. And it's x is greater than 9, so we are going to the right. So any number over there that I plug in for x will make this true. Or x can also be less than -1. Again, open circle at -1 because it can't actually be -1. Less than that way. Okay, so any number smaller than -1 or bigger than -9, I can plug in for x and it'll make that true. Okay, now let's go ahead, if your teacher wants it in interval notation, we would say this goes to -infinity, right? And over here goes to infinity. So I would say you can pick any number from -infinity to -1, right? But infinity or -infinity always get a parenthesis. And -1 is going to get a parenthesis because it can't actually be -1. Again, if this were an equal to, we would use a bracket to signify it can be -1, okay? And then this is U or union, united with. It can also be from 9 to infinity, and both of those get parentheses as well, okay? So these two are the same answer, just written two different ways. Okay. All right. I'm going to link a playlist with a bunch of other examples if you need them. Thanks.